Today we will be solving the portal gun calibration problem. The problem says Rick has been traveling through the multiverse with his portal gun, but something has gone wrong with the device. It's supposed to navigate based on a series of numbered markers, but some of the markers are missing or corrupted. These markers can be positive, negative, or zero, but only the smallest missing positive marker is needed to fix his portal gun. So basically, we are given a collection of markers or numbers which can be negative, positive, or zero itself. The question is asking us ultimately to find the missing marker, which is the smallest positive marker. Alright, so we have to find the number that is the smallest missing from the marker list. Alright, you can see the input format. The first line is basically the number of test cases, then we have the size of the array, and then the array itself, right? And the constraint, the size of the array could be less than 10 to the power 5. Alright, if we look at the sample input, the first line is the number of test cases. Then we have a three array of size 3, 1, 2, 0. So if we look into it, we have 1, which is the smallest positive number. We have 2, which is the next smallest positive number. And here it should be 3, right? But it is 0. So since we cannot find 3, that will be our answer. So we'll output 3. The next you can see it is a 4 size array, so array of size 4. We have 1, but 2 is not there, right? So we'll output 2. And the last one, there is no 1. So we'll output 1. Now let's look at the solution. The first approach is the brute force approach. In this, we make use of two nested loops. The outer loop will run from 1 till the size of the array, and the inner loop will scan through the array for every element of the outer loop, whether it is present or not. If it is present, then we move on to the next element, to the next number of the outer loop. If it is not present, then we return the number because that will be the answer. We'll repeat this operation, and since this is a nested solution, it will be a quadratic complexity or n square complexity, and it will be very inefficient for arrays, larger arrays. So we want a much more better and optimal solution. We can improve upon the brute force solution by sorting the array and checking for the sequencing of the first n positive integers. If we cannot continue with the sequence, or there's a break in the sequence, then that will be the answer. The optimal solution relies on cyclic replacement techniques, similar to that of cyclic sort. The core idea here is to place every element in the array at its correct position. For example, if I have 1, I want the next number 0 because that is the first positive integer. If I have 2, I want it at index number 1 because that is the second positive integer. Similarly, I keep swapping every element to its correct position. Every valid element, I should say. A valid element is basically a number that is greater than 0 and less than equal to size of the array, because I know that my answer will be lying in 1 till n. It can never be negative, it can never be 0, it can never be greater than the size n. After doing the swapping, we just check the array to find the first missing positive number and we'll return that. This is a linear solution with a constant space. Alright, so this is the code. Initially, I am iterating over the array, and for elements those which are not valid, that is elements which are less than equal to 0 or greater than size, I am just ignoring them. If those elements which are valid, I'm basically doing this. So this is the sample input. So I'm iterating over the array, right? So initially at 0 I have 3, which is valid. So for 3 is not supposed to be at 0, right? By the logic of cyclic sort, 3 is supposed to be at index number 2. So I'll swap 3 with whatever element is present at number 2. So to get this, then I'll move on to process 4, that is at index number 1. And I'll swap 4 with whatever is present at index number 3, right? To get this array. Now, whenever I'm doing a swap, I'm also doing I minus minus to make sure that I'm not ignoring or missing out on every node that is being swapped, right? So I'll after this swap of 4 and 1 has taken place, I'll still be at this index due to I minus minus, and then I'll process 1. 1 is not supposed to be at index number 1, it is supposed to be at 0, so I'll swap these two. You can see one is swap with -1 to get this final answer. Now we cannot process further, right? Every element is at its correct position. Every valid element is at its correct position. At the end, I'm just iterating again to check for the sequence. If the sequence is breaking, I'll just return the part where it is breaking. Else, I'll just return the size +1 because I couldn't find the element inside the array. So it will definitely be a element just after the array, just after the size of the array. So this was the code. Thank you very much.